Project selection methods. There's a number of different ways that we could select a project. This is typically done at the portfolio level within an organization, but could potentially happen at a higher or lower level. It depends on the organization structure. The mathematical approach is something that you need to know exists and could potentially be used. However, it's very unlikely that you'd ever see this on an exam. The comparative approach is what you will more likely see, as this is much more conducive to a multiple choice question. This is where we're going to measure the benefits in some capacity. A scoring model could include some type of a scorecard. A scorecard is where we will evaluate multiple criteria with weighted scores based upon how we prioritize those objectives. For example, I may go ahead and put a weight of 3 for schedule, a weight of 2 for cost, and a weight of 5 for quality. And then we can go ahead and evaluate potential projects based upon that, and whichever one would have the highest relative score would be the one that we would select. Peer review could involve just asking other project managers within the organization which project do they think would add the most value to the organization. A murder board is where we will have a panel of people within the organization that will do everything they can to poke holes in our argument. So if I bring you a presentation and I say that if we do project A, we can make $5 million in 36 months, questions would immediately arise. Where did you get these numbers from? How certain are you about the schedule? What do you think about the delivery? What about permitting? Is it feasible? And so on. This forces one of two things to happen. Either I will go back and refine my argument until such a point that it becomes basically bulletproof, or I'm going to realize that maybe my plan wasn't such a good idea and we need to abandon it and look elsewhere. The economic models we will be exploring over the next several slides. Benefit cost analysis is a simple ratio where we compare the project's benefits to its initial costs. So if we have a project that generates $125,000 in benefits and costs $50,000, we would draw the ratio as being 125,000 to 50,000. If we divide both sides by 25,000, we could write it as a 5 to 2 ratio, or we could go ahead and reduce it down to a 2.5 to 1 ratio. Now, obviously, if we have a 2-1 ratio, we can eliminate that altogether and just put 2.5. So the benefit cost ratio would be 2.5. This indicates that we will receive 2.5 units of benefit for every 1 unit of cost that we incur. This is strictly for projects where we are only concerned with money. If we're concerned with money and schedule, then we'd use some type of a scorecard. If it's just money, then the benefit cost ratio is one quick way to evaluate the relative value that a project could deliver. With payback periods, we're concerned more so with how long will it take to recoup our initial expenses. This is number of periods required to recover a project's cost. So if we have a project that cost $1 million and we're generating $100,000 per year, the payback period would be 10 years. If we had another project that cost $10 million and generated $2 million per year, the payback period would be 5 years. If the primary focus here is to recoup that initial investment, then we always want to select the one that has a lower payback period. Again, this is looking at a single criteria to make a determination. If we were worried about money and schedule, we'd go back to a scoring model. There are several concepts on this slide that you need to be familiar with, but will probably not have to calculate. A discounted cash flow is where we look at, in today's discounted terms, what the value of a project would be given inflows and outflows of money over a period of time. So as a project proceeds, how much money do we have to spend versus how much money we'll receive at various points. With present value, this is where we will calculate the value in today's money of a future cash flow, which would have a lower value. The theory behind this is that due to inflation, which is just a fact of life in our economic model, today's money will always be worth more than any future money. So we're basically doing a currency exchange. It's almost like flying to a foreign country and swapping out cash. We're saying how much is that money worth in our current money. So we have an example here of receiving $1,157.62 in 3 years. What would that be worth today if the interest rate is 5%? So the formula is written as present value equals future value divided by 1 plus interest rate to the power of n, which is the number of periods. We see that the formula is calculated and the present value is $1,000. So that $1,157 inflow is worth $1,000 in today's money. Net present value is the sum of a series of discounted future cash flows offset against the initial investment. So if we continue the example from present value and say that, okay, it was $1,000 for those future cash flows. If the initial investment was $500, we would subtract that from the present value. So 1,000 minus 500 would give us a net present value of $500. The internal rate of return is where we are trying to calculate the interest rate to get our net present value to 0. Since we still had $500 of net present value in the previous example, we would have to increase the interest rate to reduce the amount of money remaining. So it'd be a much higher interest rate to get NPV down to 0. We always want to choose a project with the highest positive IRR. If it is a negative IRR, then it's just not a good situation. Cash flows are reinvested at the IRR rate. Here we have an exercise for some of the equations that we saw in the previous slide. Assume that the project costs $10,000 in today's money and will return $2,500 per year for 5 years. So we have an inflow every year of $2,500. Your required return on investment is 10% should you do the project. The benefit to cost ratio. The benefit will be $2,500 times 5, or $12,500, to a cost of $10,000. If we go ahead and divide both sides by 2,500, we have a ratio of 5 to 4. And we can go ahead and divide that by 4 and get 1.25 units of benefit for every 1 unit of cost that we spend. Payback periods. How long will it take to recoup our initial investment? Well, for making $2,500 per year, after 4 years, we'd be able to pay back the original $10,000. The net present value. Now again, since we are dealing with inflows by year, we see that the number of periods varies as we have each one representing 1 year worth of inflow. The net present value here is negative $523.03. This indicates that we are spending money for the privilege of doing the project. While in some situations, we may have projects that do not generate revenue. If we think about something like maybe some type of ecological site remediation or some type of social welfare project, or perhaps some type of advertising campaign, we're not realizing immediate monetary benefit. However, if we're doing that type of a project, it's very unlikely that we would use this model to make a determination as to which project to select. If we see a negative net present value, that indicates that we were interested in the money a project could make, and we realize that we're actually going to lose money. That's not going to be a good thing, and we do not want to select that project. The internal rate of return. Since we have a negative value for the net present value, we're going to have to look at a reduced interest rate in order to plus up our NPV back to $0. In this case, the IRR will be 7.93%. The calculation is very complex, as when you think about your exam where you have scrap paper, pencil, and a basic calculator. The terminology on this slide is really good to come back and review later on. Sunk cost refers to the amount of money that we've spent on a project to date. When we're making a determination whether or not to complete a project, the amount of money that we've spent should be disregarded. The question should revolve around whether or not the organization can still derive some type of value by the completion of the project. The working capital. This is how much money the organization has access to minus its current liabilities. With depreciation, we have both straight line and accelerated. If we think about purchasing a car, as soon as you go ahead and buy it, you experience accelerated depreciation. As soon as you drive it off the lot, it immediately drops down to more of a Kelley Blue Book style where it's so many cents per mile or so many dollars per calendar year. Assumptions should be recorded in an assumptions log. An assumption is anything that we believe to be true or something that we're taking for granted without having some type of proof or evidence. For example, we may go ahead and assume that more funding will be available during the next fiscal year, even though that might be 10 months away. A constraint is some type of a factor that limits our options. It's any restriction that's placed on the project. So it could be resources, schedule, budget, or scope. At an absolute minimum, all projects have the three constraints of schedule, budget, and scope. No project has an absolutely open-ended schedule where they say, we don't care when or if this ever gets done. Nobody has a limitless budget where they say, money is not an issue. Here's a blank check. We'll give you more if you need it. And no project lacks some type of a scope where they tell you what they want. It'd be very bizarre if an organization said, you have 1 year and $10 million, just make something. A requirement is a condition or capability that is required to be present in the product, service, or result, or deliverable, to satisfy an agreement or other formally imposed specification. The requirements that we capture from our stakeholders or from the agreements or contracts that started our project will ultimately become our scope, and that's how we will define our scope. Progressive elaboration is an iterative approach of increasing the level of detail in the plan as greater amounts of information or more accurate estimates become available. We will progressively elaborate almost every plan that we come up with in the entire project management plan. In the beginning of the project, we're going to have very little information available. As more information becomes available, we will go back and update those plans until we have enough planning completed where we feel confident in the ability to successfully execute the project and create our deliverable. Opportunity cost is the potential benefit sacrificed by selecting a different course of action. Opportunity cost is based upon assuming that we have two or more choices that are mutually exclusive. So imagine for a second, if you will, if you have four friends and they all want to go on vacation with you. They're willing to pay for the entire thing, but they all want to go the exact same week. If you choose to go with one, then you lose the other three options. So you want to choose whichever one is going to be the best. It's going to add the most value. It's a little bit easier as we're looking at projects and delivering monetary value to an organization because it's much easier to quantify and compare. So Project A has an expected monetary benefit of $5 million, and Project B has a monetary benefit of $3 million. So the opportunity cost of choosing Project A is the loss of Project B. So the cost of choosing A is the loss of the $3 million delivered by B. Now the cost of choosing Project B is the $5 million loss of benefit from Project A. Obviously, since we are losing an opportunity to make money, we want to lose the least amount of money possible. So we want to go for the lowest number possible. This is a spectacular summary slide, and this is a great thing to come back and look at while you're doing your review prior to sitting for your exam. Certain values should be high when selecting a project. A benefit to cost ratio. I want to receive as much benefit as possible for the amount of cost incurred. My net present value. I want that to be as high as possible. And we want to reject any negative value. The internal rate of return should be as high as possible. Again, we saw it when we had a positive value for NPV, we have to increase the IRR to get NPV down to zero. And a return on investment. Obviously, we want to make as much money as we can for the money that we invest. The two numbers that we want to have as low as possible are opportunity cost and payback period. Opportunity cost should be low because it reflects the amount of money that we are losing by selecting a mutually exclusive option. And payback period should be low because this is how long it takes to pay back our initial investment on a project.